Welcome to Senior High School Math Series. Let us have binomial experiment under statistics and probability. Here are our learning competencies. Illustrates binomial experiment, identifies a binomial distribution, finds the probability for a number of successes in a number of trials of a binomial experiment. And lastly, find the mean, variance, and standard deviation of a binomial distribution. Let us begin with ponder on this. A lot of practical situations or day-to-day experiences that are subject under probability problems have only two possible outcomes, or at least can be reduced to two outcomes. When a coin is tossed, it can land either heads or tails, for example. In any type of sports, an individual or a team either wins or loses. When a child is born, it can either be male or female. In exams, a true or false type of question can only be answered in two ways. Although there are many possible outcomes in some situations, they can be reduced to two outcomes. In rolling a single die where there can be 6 outcomes in the sample space, the one rolling the die may set his outcomes as either odd or even number of spots that will appear on top of the die. In exams where there are 4 or more choices, they can be reduced to 2 outcomes as correct or incorrect answers. In medical practice, a treatment can be classified as effective or ineffective based on the results. The situations mentioned above are called binomial experiments. Let us have a recall of important concepts. In counting techniques during junior high school, you learned about combinations. The number of combinations of n different objects r at a time is the number of different selections that can be made of r objects out of n objects without giving attention to the order of arrangement within each selection. The formula for choosing r objects from n number of objects is given by n combination r equals n factorial over n minus r factorial times r factorial. Say for example, we're looking for 10 combination 3. From the formula, n equals 10 and r equals 3. Hence, we have 10 factorial over 10 minus 3, that is 7 factorial, times 3 factorial. To solve this, we need to expand 10 factorial in the numerator. 10 times 9 times 8 times 7 factorial. To make the computation easier, we stop at 7 factorial since we have a 7 factorial in the denominator. However, 3 factorial must be expanded, so we have 3 times 2 times 1. 7 factorial over 7 factorial is 1. 9 over 3 is 3. 8 over 2 is 4. So the expression on the right-hand side of the equation is reduced to 10 times 3 times 4. Hence, Let us get the given information. N is equal to 4 because there are 4 trials in this experiment. The probability of getting a 2 is 1 over 6. Hence, the probability of not getting a 2 is 1 minus 1 over 6, that is 5 over 6. Let us have letter A. X is equal to 1. Probability of x equals 1 is 4 combination 1 times 1 over 6, that is P, raised to 1, times 5 over 6, that is Q, raised to 4 minus 1. 4 combination 1 is 4 factorial over 3 factorial 1 factorial times 1 over 6 times 5 over 6 raised to 4 minus 1, that is to the third power. 4 factorial over 3 factorial is 4 multiplied by 1 over 6 times 5 over 6 cubed is 125 over 216. We can simplify 4 over 216. 4 is 1, 216 is 54. Then the probability of getting 2 spots once is 125 over 6 times 54, that is 324. Let us have letter B, twice, so x is equal to 2. And the probability of getting 2 spots twice will be 4 combination 2 times 1 over 6 raised to 2 times 5 over 6 raised to 4 minus 2. 4 combination 2 is 4 factorial over 2 factorial 2 factorial. 1 over 6 squared is 1 over 36. 5 over 6 raised to 4 minus 2 is 5 over 6 squared, so we have 25 over 36. 4 factorial is 4 times 3 times 2 factorial. Then we have 2 factorial. The other 2 factorial is 2 times 1. Times 1 over 36 times 25 over 36. We have 2 factorial over 2 factorial, so that is equal to 1. 4 times 3 is 12. So we have 12 divided by 12 is 1. And then 36 divided by 12 is 3. So we have the probability of getting 2 spots twice is equal to 25 over 2 times 3 times 36. That is 216. Next, let us have letter C. X is equal to 3. So the probability of getting 2 spots 3 times is equal to 4 combination 3 times 1 over 6 raised to 3 times 5 over 6 raised to 4 minus 3. 4 combination 3 is 4 factorial Number 3. The probability that a Filipino Asian Games 2018 medalist is a woman is 6/10. If 5 medalists are selected at random, find the probability that at least 3 of them are women. From the given information, n is equal to 5 since we are selecting 5 medalists at random. That has the binomial distribution can be found using the following formulas. The formulas for mean, variance, and standard deviation for binomial distribution are algebraically equivalent to the formulas for mean, variance, and standard deviation of the variable for probability distribution. Hence, the formulas for the mean, variance, and standard deviation for binomial distribution are simplified formulas. The derivation will not be shown in this presentation. However, it will be shown here that when the formulas for the mean, variance, and standard deviation of a variable using probability distribution, the answer will be the same. In tossing a coin 3 times, the probability distribution for the number of heads is as follows. If x is the number of heads, then the probability of x are as follows. Solving for the mean, that will be equal to the summation of the product x times p of x. So we have 0 times 1 over 8 plus 1 times 3 over 8 plus 2 times 3 over 8 plus 3 times 1 over 8. And this is equal to 3 halves. The same answer in the formula for the mean of binomial distribution. Solving for the standard deviation, that is the summation of the product x squared times p of x minus the square of the mean. So we have 0 squared times 1 over 8 plus 1 squared times 3 over 8 plus 2 squared times 3 over 8 plus 3 squared times 1 over 8 minus 3 halves squared. The answer is 3/4. And to get the standard deviation, we get the square root of the variance, that is 0.87. That will be all. Thank you for watching. Please subscribe for more math lessons.